Alright, section 7.1, radicals and radical functions. All of chapter 7 is about radicals, and then later on in chapter 7, we get into imaginary numbers. Um, so our first objective is find square roots. So our example, we're going to find each square root. Remember, square root is the same number multiplied by itself gives something. So for 49, the square root is 7. It's 7 because 7 times 7 is 49. That's also 7 squared is 49. Alright, moving on to part B. So when we have a fraction, we need to make sure that we understand that it goes to both top and bottom, because since it's over the whole thing, if it's over the whole thing, then it's over the top and it's over the bottom, so separate it. You need to separate it because later on in this chapter 7, it's going to come in handy that you know how to separate it. So the square root of 25 is 5, and the square root of 16 is 4. Alright, next we have the negative square root of 4. So that just means negative, and what's the square root of 4? 2. Alright, the square root of 0.81. So this one's actually easy. Decimals might seem hard to find the square root, but they're really not, because what's the square root of 81? It's 9. So it's 0.9. It's always that way. So if it's the square root of 0.25, it'd be 0.5. Alright, now we have letters involved. Pay attention afterwards, so we'll get to those. The square root of 9 is 3. Now, I don't know if you know this, I hope you do, but the index is 2. Now, if you don't know what that is, if you don't know what I'm talking about, this is called the radicand. That's the square root. And that's the index. So the index is saying what two numbers are the same. That's why for 49 it's 7 times 7. Those are two numbers. So if it was the index of 3, that's 3 numbers. What's the cube root? If it was the index of 4, it's what times what times what times what. 4 times gives me that number. So in the radicand, whatever it is, you're going to divide it by the exponent. So 10 divided by 2 is 5. There's nothing left over. So the square root of x to the 10th is x to the 5. We will go over more with variables later on. Don't worry about it. So we have the negative square root of 25, which is negative 5. There we go. And then here we have the square root of negative 25. When it's an even index, you can never have a negative radicand. So in this case, the answer is no real solution. Because you guys might know that you can simplify that to 5i. But if you don't, we're going to get to that later on in this chapter. Alright, approximating square roots. So approximating square roots, if it says to approximate, then that means to use your calculator. So put that into your calculator, and it comes out to approximately 2.234. Square roots are always exact. Decimal is always approximate. So if you see exact, that means leave it as a square root. If you see approximate, that means make it in a decimal. Alright, objective 3, finding cube roots. So cube roots mean that the index is 3. So it's what 3 numbers multiplied to the radicand. So for 27, that's 3, because 3 times 3 times 3 is 27. Negative 125, you can have that because the index is not even, because negative 5 times negative 5 times negative 5 is negative 125. You do get a negative out of that. Alright, remember we have our fraction, so you want to separate this. So we have the cube root of 8 over the cube root of 125. So the cube root of 8 is 2, and the cube root of 125 is 5. Okay, remember, if it's an even index, it cannot be negative. But if it's odd, so 3, 5, 7, 9, all those indexes, you can have a negative on the inside. That is fine. So the cube root of negative 8 is negative 2. And remember, we're going to see how many times can 3 go into 9. Well, 3 times, so that's x cubed.